Hello, hello, COTI community. Hello to all the builders. Thank you for joining another developer community call. We are, as usual, very excited to talk with our builder community and help you get started building your DApp, your private DApp over COTI. So, as always, I have today the team, Spencer, Eitan, Daniel, David won't be joining us today. Let's kick the tires, let's get going. So a recap from our last call. So in our previous call, we've basically gone over the updated documentation, showing you the changes we have made and what each section contains. We feel like, and we also got great feedback on the updated Git book, that it will really help you guys get started and find whatever you need to go ahead and integrate with COTI's testnet. Let us know. Share the details with us. Do you also find it very easy to use right now with updated version? Yes, no? We really love your feedback. We also discussed changes that have been made in the Web3 Py and ethers.js, showcasing the new packages and new abilities and how to develop on top of it. So about today's content, we'll touch brief on that in a sec. As always, our development resources is our docs.co.io, as I mentioned, the rebranded one, basically improved per your feedback and per the things that we saw developers need or according to their questions. So we changed that. The testnet explorer for you guys to see all new transactions, and the COTI.io GitHub, as always, with the SDKs and so. So if you need anything else, if you think something is missing as a main development resource, let us know. Follow us on GitHub. We really treasure our community and we love your feedback. Show support, put a follow on the company's GitHub page, and start your favorite repo. So today's topics: how to write a private smart contract. So as I mentioned, our last call was about how to use ethers.js and Web3 Py. Now we want to cover something on actually writing a smart contract from A to Z, a private one, of course. Spencer will be sharing his screen now, showing you how to do that, and then Eitan will continue showing you how to interact. Everything is already in the guides in Gitbook, so go ahead, tune into this session, because I'm sure you guys will find it very enriching on how to do private smart contracts from scratch. Spence?
Just gonna share my screen. Cool. Can everyone see my screen?
Yep.
Cool. Hi, everybody. For those who don't know me, I'm Spencer. I'm a developer at COTI. Today, I'm going to be giving you guys a high-level overview of how to write a private smart contract, how to work with our Solidity libraries. So I've prepared a small example that I think gives a great introduction to most of the core concepts, but if at any point you have a question as to what I'm doing or why I'm doing something, please write in the chat, and somebody else in the chat, maybe Daniel or Guy, will let me know that someone has asked a question. So I'll just jump right into it. So what I've done is I've opened up here the Remix IDE. I'm sure most people are familiar with it. And what you might notice here is my side panel looks a little bit different. And this is because I've installed our COTI Remix plugin. So just as a reminder to everybody that you can see you can install the COTI Remix plugin by going into the Plugin Manager tab and scrolling down until you see COTI. It's in alphabetical, so should be somewhere around here if you haven't installed it already, and click install. It looks like this, and once you've opened it up, what's really nice is that if you click this little button here, you can have this little link to the documentation. In case you have any questions on how to do it, we've also had a previous developer call where we really explained it at length, so I won't go into too much detail now. But anyways, so I have the COTI Remix plugin installed, and I've created this really basic smart contract that at the moment does not have any privacy features. So it's a really simple contract, and all it does is it keeps a running total of a sum and a sum state variable, and it has one function that changes the state. You pass in a value and it adds it to the sum. And then we have a view function that returns it for us. And what we're going to do is we're going to convert this function into a similar function that uses privacy features. And I'll be explaining to you guys every step of the way on how we might do that. Any questions so far in the chat? Anything? No. Cool. So the first thing that we're going to need to do in order to start to take advantage of the privacy features of COTI network is to import our smart contract library. This library is available by NPM, and in Remix you can really just paste in this line of code right here, and Remix will import it for you, which is really, really nice. So one way that we might change this contract in order to take advantage of privacy features is to change this add function to be a encrypted value. Sorry, actually, first what we'll want to do is to change the type of sum. So right now our running total, our sum variable, is a uint64, which is not encrypted in any way. So the first thing that we'll want to do is to change it to be one of our encrypted data types. So since I've imported the MPC core library, I have access to all of our types. So the first thing that I'll want to do is change the type of the sum variable to be uint64. Now, uint64 is one of many UT type variables, data types that we have, and UT stands for combined text. Now, combined text has two parts. It has the ciphertext and the user ciphertext. These are two encrypted values. One of them is encrypted using the network key, and one is encrypted using our AES key. We've talked about the AES keys many times in the past, but I'll just give a brief reminder. Our AES key is the encryption key that we use to pass encrypted data onto the chain and also to store data in an encrypted form. Any questions so far in chat? Nothing yet. Okay, that's good. So far, so good. Everyone's following me. So what we've done so far, all we've done so far is change the type, the data type that we're using to store our running total. Now our running total is an encrypted form, and we can continue making more and more changes to turn this contract into a privacy-enabled contract. So the next thing that we'll want to do is to change the type of our input. Oh, also, because we changed the type of the sum value, we have to change the return type in the view function.
Just a sec, Spence. So Raul is asking, what's the purpose of using COTI data types, anything special? So Raul, about that, in order to utilize our GCVM capabilities, such as encryption of data and making on-chain computation, a smart contract that is being developed in a private manner has to use those special data types. Now, in the background, those special data types are basically integer representation, but still they are used in order to enable you to do on-chain computation. You can't do that just on any other data type. You need to use those specific ones. If it was, if you need any more details, got it. Okay.
Great. So I'll continue. So right now we have basically the exact same contract we had before. All that we've done is changed the type of the sum, the running sum state variable, to one of our encrypted data types, specifically the UT type, which is used to store encrypted data in the contract state. And this clarification is important for many reasons, which I will touch on soon as we continue with the example. So the next thing that we'll want to do, since we've encrypted the value that is stored in the contract, naturally what we'll want to do is to encrypt the value that we're passing in to the add function. Otherwise, for some other user who's monitoring the chain, maybe they can't see the value of the sum state variable, but if every value that we add to it is clear, then they can easily deduce what is the current sum. So what we want to do next is to change the value, the data type of the value parameter to an encrypted type. So to do that, we'll change from uint64 to ituint64. Now, ituint64 is one of many IT type data types. IT stands for input text, and input text is an encrypted value that is used to pass a value into as a function argument. And this is important because it has a very different structure to, let's say, the uint64 that we use, that we're using to store the current sum. So input IT type values have two components as well. One is the ciphertext, and the other is a signature. And you can generate these values really easily using our different SDKs. And basically, you encrypt the value and you pass a signature to prove that you, in fact, generated this encrypted value. So now that we have an encrypted value passed into the function, you might think that we're ready to go and we could simply just deploy the function, the contract as is. However, that is not the case. And the reason for this is that, among other reasons, is that sum and value are not of the same type. So we can't just add them as we normally would with two, let's say, uint type values. So what we'll want to do first, when we're working with a IT type values, all IT type values, in order to perform any computations with them, we need to convert them into what we call GT type data types. GT stands for garbled text. I'll write this. GT is garbled text. And this is yet another encrypted data type that we have. And the purpose for, or the use case for this data type is strictly for performing encrypted computations or computations on encrypted values. So in order to compute against any encrypted value, you need to bring it into this type. So there are different ways to convert values to GT types. So starting with the IT type that we passed in, what we'll want to do is we'll want to use the MPC core function called validate ciphertext. MPC core like so. Compile just to make sure everything is. What's the problem here? Okay, this, yeah, as expected. So what we've done here, what I've just done is added this line here where we call validate ciphertext, and we pass in our value, our encrypted value. And what this function does is it validates the signature that I mentioned, make sure that the signature matches the ciphertext that is provided, and it returns the same value, but this time it's encrypted using in a GT type data type. Great. So now this value that we passed in here is now ready to be used in encrypted computations. So why is it that this line here, where we add value to our sum, is producing an error? And the reason is very similar, is that sum, it's in UT data type, and so we can't compute on UT types, so we need to convert it as well into a GT type value. So the process is very similar, but this time, since sum is not an input text, we don't need to validate it. What we need to do is onboard it. Onboard, basically bring it into memory in a GT type. So there's another MPC core function for this, and this one is called onboard. And onboard accepts the sum, but only the ciphertext. The ciphertext that is encrypted using the network key. And now we have two GT type values in memory. But again, if I try to compile, you see that it still produces an error, and this is because the traditional addition operator does not can't accept two GT type values. So again, we need to use another function provided in the MPC core library, which is our add function. So in order to add, let's say, the encrypted value to the sum, we could do something like this: MPC core add, and we want to pass sum and value. And finally, you might think that we could simply do something like this. Just store the value that we just computed in the contract storage. However, compiling this contract produces another result, and it says that we can't convert GTU into UT type, which is true, but also we can't even store GT types. Like I said earlier, GT data types are only used for performing computations on encrypted types. So in order to change a GT type,
if I may just throw in a comment, you can store it, but you don't want to because it has no use. It's a runtime on the fly variable kind of thing, used for transitions.
Yes. So in order to make sure that that the value can be used for further computations, what we need to do is call this function called offboard. In this case, offboard combined. Oops. And we pass in the sum and the sender whose key we will use to encrypt the value. Now, I specifically used offboard combined as opposed to, let's say, offboard, which is another function that we have, or offboard to user, because I want this function to return to me a UT type, which holds the value encrypted using the network key, as well as with the user key.
Just a sec. Rao had a question. So he's asking whether when using GT types, you could use the memory keyword. So yes, since those are for memory use only. Right, Spence?
Yes. You could like pass, maybe he means like if you have an internal function that accepts a GT type, let's say you want to reuse some logic and you want the function to accept GT type, then yes, actually you don't want to use them. You can't use the memory type. Let's say as a function, the memory keyword, sorry, because the type is it's an alias of a primitive type. It's not a struct. So actually you wouldn't use the memory. Let's say if we had something like function like this, and it takes GTUint64 value and or let's say it takes A and something like this. I don't know if this is what you have in mind, Rao, but feel free to write in the chat or if this is what you meant, or clarify if you meant otherwise. Let's say we wanted to reuse some logic like so. So we would say, notice that I didn't use the memory keyword here, and we would just return ccore.add a b, and here we would be able to just replace this like so. Why is this? Oh.
So basically, I think what he meant was to define, for example, the value that's on GTUint64 as a memory and not as a storage variable.
No, but call data is for, anyways, let's move on. Cool, so this contract, we finished adjusting it in order to fully encrypt all the values, meaning the sum, the running sum, the values that we're passing in to add to it. And so now we can test it out. What I will change here, just to make sure the example works, is I'll change this to be 64, and I'll return sum dot. The reason that I changed this function, instead of returning the UT type, which holds two different ciphertexts, I've changed it just to return the ciphertext that is encrypted with our own encryption key. And this is just to make sure it works well with our Remix plugin. So what we can do now is compile the contract and press deploy. And what you'll see is that, oops, I deployed the wrong one. Great. So you'll see in the Interact tab that our newly deployed contract is here, and it's generated some buttons nicely that we can interact with it very, very easily. So just to check everything is working correctly, we can check the current value of the sum. Now, you might be asking, why is it returning a clear value here? And the answer is that it's not. The Remix plugin, the COTI Remix plugin, is automatically attempting to decrypt the values using the AES key if you have it. So I've already gone through the onboarding procedure here, and therefore the plugin is using it to decrypt the value returned by this function. And since I was the one who, oops, actually I forgot one very important thing. I forgot to put the constructor. And the reason why we have to put a constructor, sorry, I'll delete this. The reason that we have to put the constructor now in the encrypted version, or the privacy enabled version of this contract, is because the value that sum is initialized with is 0. And this is not a value that was ever encrypted properly using the MPC course. So at deployment time, what we want to do is set the value properly in a properly formatted UT type. So what we want to do here is very similar to what was done here, except we want to set the value to 0. So what I've done, what I've added here is inside the constructor, I've set the value of sum to be the value 0 that is encrypted using both the network key and our AES key. So now we're ready to deploy once more. Oops, I did this again.
Don't worry, I'll send you some coins if you need.
Sure. That's weird. Perhaps maybe my AES key is incorrect or something. What I'll do is,
Spencer, it's reading the sum value there in the view?
yeah, it's supposed to, but perhaps I have out of date AES key or something. So what I've done is I've just, yeah, I see the value is different now. So I've regenerated my AES key, and I'll deploy it one more time. Great. Okay, so now we see the value is 0. And if we click this I button, this will show us the value that is really stored on chain before it's decrypted using my AES key. And you can see the value that's stored on chain is some totally unrecognizable number. So everything is as expected now. And now we can test out this add function. So I just put in a clear value here, and the Remix plugin will encrypt it for me and execute the transaction. What you'll notice after I press transact is that this little I button appeared. And if I click it, it will show me the encrypted value that I used as input. So even though I wrote 123, if you'll look on the block explorer, for example, this is the value you would see that's passed on chain. And just to check everything worked as expected, we can now read back the sum, and we see we get 123 as expected. And this is the new encrypted value on chain. So that, unless there are any other questions, that wraps up my part of the demonstration. And basically, I hope that this gave everybody a good first introductory step into using the MPC core and how to take a contract that is not does not have any privacy features and slowly convert it into a contract that takes advantage of all the great privacy features of the COTI networks.
Great, Spence. Thank you for the great demo. If no one has any questions so far, Eitan, take the stage.
Okay, hi everyone. Here is Eitan from COTI team. Let me share my screen. Let me know if you are able to see. What I plan to do today is, is to show you a small demo or small example how to use our cotiethers over TypeScript and how to interact. 1 second. And how to interact with the contract that Spencer just created. Are you able to see my screen, guys?
It's the mirror thing now. No, yeah.
Okay.
Yeah, it's visible.
So I'm using WebStorm. I just created a simple TypeScript project. I called it example. This is how it's getting generated. Okay, so the first thing that we need to do is basically to install the cotiethers package using the npm. So let's do it.
Just a second, Eitan. I see that Rao has a follow-up question. And what he asked is that if anyone has the COTI library, I maybe meant the COTI Remix plugin or any one of our SDKs, then are they easily able to decrypt the value stored on chain? So the answer is no, thankfully. And the reason is that they don't hold the AES key that was used to encrypt the value before it was stored on chain. So when I was going through the example, in the code, we called offboard combined, and we passed in the address of the person who is calling the function, the message.sender. Yes. AES is the base of encryption, and so you can attempt to decrypt any value that you see on chain, but only if you hold the proper AES key will you be able to see the real value. Sure. Eitan will give you an example of failed decryption soon. So I hope that answers your question.
Okay, so in a few minutes, maybe I can show you how if you are trying to decrypt the stored value of sum that you just encrypt with other AES, you will get a wrong result in a few minutes. Okay, so let's start with every action, everything that you want to do encrypted on COTI chain. You must first onboarding your wallet. So let's just do this for the beginning, and let's create a function on board. Okay. I forgot. I started with the only thing that you need to install to deploy is the cotiethers package using the npm. So just run npm install as it showed here, npm install and the cotiethers package, and it will install it for you. You can check if the version in the package JSON, see if it's fit for your the other version sorry, that you're using. Great. So in order to create a cotiethers wallet, let's start with a provider. And you can use basically the cotiethers contains some helpful method, such as the get default provider, but basically you can choose every RPC or provide it to the wallet every RPC that you want. Here we are giving it the testnet RPC. After that, we will create our wallet using the provider, and you need to, of course, no, I mean wallet, and I don't want to create a random wallet, so I need to give it a private key. Let me just delete it. Before this meeting, I created a demo wallet. Let me just paste the private key for this demo. And let's import the wallet. And basically, after you run these two commands, you have a wallet, a cotiethers wallet that you can use it to interact with the chain. It has, let's call it, it's built over a ethers package, and it has a special privacy capabilities that you guys can use. Okay, the next function that you can use is that belong to the wallet and get generate or recover the AES key. As you probably everyone I'm sorry, everyone already know, the AES key that getting generated is deterministic. Every time that you will call with the same wallet, you will get the same AES. So you need to do the onboarding only once, and you can the onboarding is a transaction. It will cost you money. So after the onboarding, just save somewhere the AES key, and you don't need to do the onboarding procedure again. Just store the AES key, and let's print it. Console log get it's in and the AES key. Okay, great. Let's run it. I think I need to did the npm install. Let's see. Okay, I think so. And the onboarding is for the first time. It's taking It's taking some time. Now what, let's debug it. Let's see that everything is let me check the COTI Explorer, see if everything is okay there, because it should end by now. And unfortunately, I think
Maybe try to run without a debugger attached.
no,
Just
it's not.
make sure it's executing.
I think no, it's I run with and without.
Now you're running with, try without. Maybe the debugger has its own life.
Second. Okay, let's see. No, this is not the issue. Okay, Spencer, maybe you have a contract. Can you give me the contract that you deploy on DevNet? I will try on DevNet.
Yes, just wanted to remind you to change the package version to be the latest DevNet version. And I'll send you the address now.
And okay, great. So okay, so this is the counter contract, and I need the RPC. 1 second. Zero, one. Okay. Okay, so let's just delete the npm. Let's make sure. Okay, so I need the testnet RPC. I don't remember.
It's DevNet COTI.io /RPC.
At DevNet. Guy, can you ping me? DevNet.
Yeah. Sure. It's at devnet.coti.io /RPC. I'll ping you.
devnet.coti.io /RPC. Great. I forgot that we have. Okay, let's see if we can onboard on DevNet for this example. And let's see what happened. I don't have balance in this account. Let me transfer some COTI very quickly.
It's a good chance to use the faucet and show them how faucet is being used over Discord.
You're right. So let's open Discord. Okay, so you can go to COTI and go to the COTI faucet and do just DevNet and the account. Great. And let's try it again. Okay, great. Let me show you the wallet. Basically, this is a ethers wallet with additional fields. The additional field is the AS key and the RSA that you, in order to generate the AS key, you need to generate an RSA keeper, and we are storing it here. Let me take it to a further use. Const AS. Okay, great. So this is the first part. We have the AS key. After that, let's communicate with the contract, the counter contract. In order to do that and to use the ethers package, we need to take the ABI of the contract. I will put it in a contracts TypeScript, and we'll copy it here. And we will, and let's call it, I don't know, counter example. And let's create it. Example. Sorry for the typo. Exam. Okay. Wait just a second. Okay, I didn't save the wallet in some common variable, so let's do it again. And let's create a const counter contract. Here we are using the contract object of ethers. It's regular, basically. Okay, the address that Spencer just created for me, I will take it and put it here. Sorry. Great, and I need to provide it the ABI. ABI counter. Let's edit. And I forgot the new. And getting the wallet. Okay. After this line, basically we have an object that can interact with the contract. Let's first see the value that we already have in the contract. It's, if you remember, we had the sum. No, sorry, this is not how we are interacting. Await contract. Dot. Let's do it in one command. Decrypt value of a wait contract dot sum. Sorry, sync and counter dot sum. I think I missed. Yeah. Okay. So this will print the current value of the sum variable. Now let's do some I don't know, let's add to this number some value. So if you remember, the IT value is wallet dot. In the wallet, in the cotiethers object, you have a method called encrypted value and decrypted value. If you providing the AES key, which I forgot to do, first you don't need to do onboard because you can set it. And if you will provide doing the onboard procedure, you can use the encrypt and decrypt value, and it will do everything for you automatically, the encryption and decryption. Okay, so let's give it some number. I don't know. Let's add it 100. This is the contract address. And what we want to do is contract dot add fragment dot selector.
Eitan, we are coming up on 5 minutes to complete the session. So I really wanted to have a chance and show them a few things. So
I will do it quickly. Let me just write it. I will do it in counter contract dot add, and we are sending it the IT value and dot wait, and let's just print the additional value. Okay, that's it. Let's see if it's worked. If not, another time. Okay, we just set the AES key. Okay, so this is the because we didn't create it. This is example that I cannot see the value using my AES key because I didn't encrypt it.
That's also a great example, by the way. That it's not readable. It's you wanted it to act differently, but that's also a great example to show that the network really keeps it secure. But that's a thing for our next session, maybe.
Okay. So, Guy.
Sure.
The lead.
Sure. No problem. So maybe you can stop the share. I'll reshare and. I wanted to use the last 4 minutes because we respect people's time and we don't want to take too much of your time. Great. So I wanted to share this Uptime COTI.io. Eitan, let me tell you, let you in on a little secret. While you try to do that on testnet, testnet has an issue. So it just happened during a demo, testnet had an issue and you couldn't send the transaction. All great demos have that, just so you know. So just to keep everyone notified, uptime.coti.io, you can see whether our environments are up or not. Now, for the coming testnet, you will be seeing a different list of components for the upgrade. We will be having an upgrade soon. We also posted a message about that over Discord. So you should plan to see this page looking differently because different components will be happening. But as you can see right now, we do have some outage and we are handling it. So FYI, this page will show you if testnet is behaving correctly or not. That's why Eitan had an issue. And Spencer, Eitan, thank you for a great demo. I just want to wrap it up with something that Daniel talked about, I think in the previous meeting, using the AI to generate a contract. So out of everything we just showed you, one of the coolest features we can present is you want to write your own private smart contract, just use AI, right? That's so normal these days. So write me a privacy-preserving smart contract that saves date of birth data in a private manner on-chain and requires an ERC token to reveal it. So I'll just ask the AI to write that. And let me tell you, not always the AI, as you know, will get it right 100%. But for sure, this is something that you could start with. So as you can see, it just output a great start for a sample of a contract that uses something called data privacy framework that you could read about in our Git docs that basically enables you to use some of our privacy frameworks. So here, for example, as Spencer showed, you can get an encrypted value of date of birth and then basically saving it for that specific user. He's basically updating his date of birth on-chain, encrypted. And then if you want to reveal it, you have to use a token. Now, the token itself, here basically the contract asks you to hold the token in order to reveal it. And that's an idea that you can use. This is a platform that you could start using, writing your contract with pre-existing knowledge that COTI has there. So we really think that's a great way for you to start. So guys, if you have any more questions, and feel free to ask it over. Let me just get back to my great presentation. As always, we want your feedback. Use the GitHub issues, use Discord, use Telegram, whatever you guys feel like that you want to give us feedback with, and share feedback on the session, on the SDKs, on the tools we provide, on the network. If you have cool building ideas, let us know. And we want to hear it. We want to hear your feedback. Daniel, Give us the RFP and Builders program. Let the community knows how they can contribute. Daniel, we can't hear you.
Now? All right, thank you. Yeah, thanks, guys. So for all of those out there interested in contributing to the COTI community, you can do so in a number of ways. So let's say if you have a project that you want to code, like a test app or some developer tool that you think would be useful, that's one avenue. Another avenue is content. If you want to produce videos, if you want to produce guides on how to do something you think would be useful for the community, that's another project that we're interested on. So head over to build.coti.io, and you can check out what the program is all about and the funds that are available to make that happen. And if you have any questions, you can always reach out on Discord, Telegram, and we'll be happy to help you with that.
If no further questions, thank you all for joining this session. I will be sharing an X poll. What you want to see next, which information is vital, which you want us to work on and present it to the community. So cast your vote and let us know. Thank you all. Have a great one.
Thanks, everyone.
Bye-bye.
Bye.